Welcome to a new lecture of software engineering, and we were discussing design concepts. This is a chapter from Pressman book, Design Concepts, and as we discussed in the last class, why design is important. As I understand, everyone in this class is going to be an engineer, and as the first job of an engineer in a company or in a different organization would be either as a programmer or as a tester. If you see the SDLC, these two posts, programmer and tester, would fit in implementation and testing. And these come after the design. And if you see the structure of a company where the design is done by software architect, and a software architect should have at least 20-year experience in software programming or software testing. And the software architect has a quite big role in software building. The building of the software is quite complex and a very disciplined job where multiple shareholders are there, and we have to see whether the team at our side can fulfill the requirements of the client. The interaction team with the client is our requirement engineering team. They had a discussion with the client, and then we did some analysis, the requirement analysis, and then we have to convert those to some design. Later we will convert them into detailed design, and then the coder will implement those designs. So when the coder has implemented these designs, we can verify that coder has done the same job what was required. So there must be a verification of the design in the code, and code is supposed to do the same thing what client has asked, and also should be according to the design given by software architect. So let's see what Pressman has described here. An example has given from Mitch Kapper, where he quoted software design as the Italian buildings from old era, and they show the firmness, commodity, and delight. And Kapper say that a software should be having these properties: firmness, that means it should be free from bugs and should do what exactly the client has asked us to make this software. It should fulfill all requirements of the customer in functionality. Commodity, the program should be suitable for purposes which it was intended. And delight, the experience for the user should be easy and transition should be smooth. This third point is very important, and we have the next section based on this. And I can tell you from my industry experience that the software team can make very excellent software which can function everything what client has asked, would be bug free, but the users of the software by the client or the people who are working at the client end, the users would be a big problem. If you have made an excellent software and people are not liking it. So the design of user interface, the design of usability would be a big issue. I can tell you one example here. You may have heard Motorola, Nokia, and later Apple. These are three big companies. Motorola was a very tested and very reliable name in embedded industry, and it used to make the equipments for military communication, satellite communication, and other type of embedded systems. They made a phone which many people used, and it was quite popular. So these phones were available in early of this century, and people used them for some time. When Nokia came in the market, different phones of Nokia, I'm talking about feature phone at this time, I'm talking about 2002 to 2008. So the feature phone was of the Nokia was quite easy to use and became quite popular. Later, people saw that although the functionality and reliability in the Motorola phone is at least same as Nokia or even better, but the Nokia phone is quite easy to use. And people who are not very tech savvy, they went with the Nokia. Later, when Apple released the smartphone, now people call them Apple phone, they became so popular because of the usability. There is no additional functionality in the Apple phone which other phones are not having, but the user interface, the way to use phone is quite easy, so that a person in 90s or a person who has never seen a smartphone can easily do everything with the phone. And this is the reason in softwares where you have people at the client end who are not very tech savvy, they may have issues in using your software. I can quote another example here which can show that how a bad user interface design can impact the performance of a very good performer in the system. So these days, there are long queues in front of hospitals for some testing purpose, and there may be different type of tests, not only COVID. There are many efficient nurses, and they can do testing and the report generation at a very fast speed. So although I have a case study of this, I will tell you only in brief. Let's say the nurse was doing one test per 10 minutes and generating the report using the old system, computer system, or the manual system. The hospital management asked us to develop a new software, and we delivered the software as per the requirement and additional functionality what hospital management asked. And the software was having everything what was needed. So when this software was installed on the hospital, nurses were using this, and we saw that now the same nurse which was doing one test in 10 minutes now takes at least 45 minutes to do the test. What is wrong now? The problem is that in the user interface, we have so many entries for the nurse to do. That's the patient name, age, blood group, previous history, and the current samples, current analysis. And when everything would be done, it will generate some report. The nurse has to wait till the report is generated, and then nurse has to do the second phase of diagnosis. So because the nurse has to do so many entries which were not there before, she was writing either on the paper or she were making it later in the system. Now she has to do everything on the computer. The patient has to wait, the nurse has to wait, and then when the system will go to next page showing some analysis, that analysis will be used by the nurse for the diagnosis. So that has created a delay in the system. So even the firmness and the commodity are there. The input of the user, the person who will use this software, is quite important from the client side. Whenever we do acceptance testing, we will ask the users to come at our place and will do the acceptance testing so we can modify the design if needed. So this figure shows how things fold in design. We would be having different type of design, let's say component design, than interface design, which would be showing how the software or the component would be interfacing to other components or to user, and then architectural design to show how the software has been made or the basic block, and class design and what you have done in requirement analysis, let's say use case diagrams, activity diagrams, class diagrams, CRC models, sequence diagram, control flow diagram. That would be useful and may be used in these designs. And later, when we will refine the model, that means after making the basic design, when we generate the detailed design, these diagrams would be very important for the next phase, that is implementation, to see what exactly the architect was thinking when designing this. So architect will make the basic design, then basic design would be having the detailed design, so the coder will look at the detailed design and can code accordingly. The design must be complete in itself. It must have all the requirements, including the functional requirement and non-functional requirements given by the clients and assumed by the requirement engineers. The design must be readable, verifiable, and easy to understand by different people, because you may be knowing this, we have at this time 10 programmers, 4 of them may resign and we have to recruit 4 new. So when the team changes, the design, same design, we have to implement, and that design must be understandable by everybody, either new or old person in the organization. Similarly, in the testing team, they will get the code for the black box testing, even for the white box testing, and they also would be having access of these designs, including detailed designs. So the tester has to check whether the coder has implemented in the same way as design was given. It is possible that coder has implemented and it is fulfilling all the requirements, but the coder has not followed the design. That will be a big problem, because a good design can have bad code, but a bad design cannot have a good code. It means if a good design has been implemented badly, a bad code can be rectified seeing the design, and the software quality can be improved. But if the design is bad, even a good code cannot improve the quality of the software. And a bad design is a disaster for the cost of the software. And cost is a big factor in the organization which has taken the contract to build the software. The design should provide a complete picture. It should discuss the data and other requirements, and in the detailed design these things should be from implementation's view. Generally in design we don't consider programming language specific design, although as we know that we would be implementing this in, let's say, object-oriented programming language, Java or C++. In that case, we may include few things in detailed design if needed. So there are a few guidelines about the design which are listed here. So design should show an architecture which should be based on standard patterns or on some styles where the style can be based on his or her perception. Design should be modular. As we discussed modularity, we'll see that the modular software is cost effective and also easy to remodel and easy to debug. A design should have distinct representation of different things in the software like data, interfaces, internal interface, external interface, user interface, and different components. The design should lead to data structure that would be appropriate. So the classes which we are making in the design, they may have some data structure and that the programmer has to implement if it is given in the design. And this may be based on standard patterns. The design should be based on components and connectors as given in point 4 and 5. The 6 is the design should be derived using a method which can be repeated again and again, like we have obtained the information after requirement analysis, and that if needed can be done again. The design should use standard notations or architectural languages which are widely accepted. Now when we talk about quality, quality has different attributes. These are functionality, usability, reliability, performance, and supportability. There are books which will add 2-3 more, like maintainability or durability. So let's see them one by one. Functionality is about the feature set which it is having, the functions it can deliver, and those are generally based on requirement analysis. We can have some other things like security, and these days the cyber security, which generally the client will not tell you because there are different ways a system can break, and those would not be known to the client. Usability, as we were discussing, the users at the client end would be having different issues in not understanding the user interface, not understanding the flow of the software, or maybe some other issues. Let's say there is no consistency, the documentation is not proper, and may create many understanding issues for the normal user. reliability. This is the term which was mainly used in mechanical area where the hardware system used to fail, and we had different terms like mean time to failure, mean time to recover, etc. Although in software, when Six Sigma was applied, these terms are also applicable now, and we also see the reliability of the software by measuring the frequency, how many times the software fails in a given period, what is the average time to recover, and whether it is recoverable easily or not, and can we predict when this program is going to fail or how long this software will go without failure. So when we can see that a software can run for a long time without failure based on our mathematical calculation, we can assume that software is reliable. And reliability in a software creates the market value. For example, you know that there is a ticket booking agency or a ticket booking website, and this is quite reliable. It will never cheat you and it will never fail. So whenever you are booking your ticket, it will run and will not crash. So this is a faith of the user as well as very important for the company. Another example is Amazon website. They know that if their system is failing, they would be having a big loss. And we also know that using Amazon or using Google, they are generally available 24/7. On the other hand, there may be few websites which would be having very small MTTF, and that will create issue for the user and big issues for the company owner. And users generally avoid these websites or these softwares which regularly fail. Performance, so generally measured by the speed, the response time, and the throughput, how efficient it is. Efficiency is a relative term. Although in different organizations, the performance can be measured in different ways. Supportability. Every year there are few changes in the organization. Also, there are requirements of the user which changes from time to time. So once somebody has asked you to make a software, to develop a big software, next year they will not ask you to do the next one. So they would ask you whether something can be added, the extra functionality in the software which you developed last year. So whether the software is extendable, whether the extension can go smooth, whether the extension would be adoptable by the user, would be adoptable by old systems, and if something goes wrong, how good it would be to service this. So there are different factors based on that. The quality of the software or the design we have to measure. Now there are few design principles given by Davis, and these are quite useful when somebody is designing the software. When you would be having your software engineering lab, you would be designing a software, and that time you have to do the requirement analysis, design, coding, testing, everything yourself. So you would be using these at that time. So the person who is designing the software, the person should be having, or the team should be having a broad vision and should see the software from different angles, should not go with a narrow vision that would create some problem later. So if we can check different aspects, can check different views, and can discuss on different points, that would give our design a better quality for improvement and extendability, and also client would be happy to see a software which can accommodate different things. The design should be traceable to analysis model. So as you have seen that we brought design from different diagrams of requirement analysis. So if we want to back to requirement analysis, that from where we got this design, and can we go back to requirement analysis to check whether this was really needed or this is what client has asked us to do. So that should be traceable. Point 3 is very important in software industry. If something is available to you, you should use it, should not write it again. And this is normally called do not reinvent the wheel. And we also have a different name for this in software industry, reusing the software. So if you have an old written code, an API, or something with you, just use it and make the software. Build your software. I'm assuming that you have the copyrights for that old code and the API, or this is public API like Java API. If you are writing your own code for something which is already available in the market or available as open API, that is wastage of resources in SDLC. Point 4 is again quite important. The software you would be making, that should minimize the distance between the software and the person who is seeing the problem, because that problem is in the real world. So your software should tackle the problem as the real person in the real world would be having. So your software should not be needed some extraordinary requirements from the user to handle it, and should be easy to use and easy to go. Point 5, the design should show uniformity in all the parts and should be smooth integration. So if somebody that is step 4 and somebody that is step 8, a uniform view and uniform structure should be there. So once the person has learned one module, that person should be capable of handling other parts without learning new things or without going under training. Point 6, as we have discussed, the design should be structured to handle the changes, because change will be there. If you have made everything what client had asked you to do, the client will see the available product which you are delivering now and will say, okay, we said this last year, but now our requirements are like this. Or, yes, we said this during the requirement analysis, requirement gathering, but now we don't want this, we want something else. So there would be changes till the last minute, and this is very normal. So the software which you are making, that should be modular, and if it is modular, it would be easy to handle any change, to add any module, to modify any module. And if the modules are talking to other modules using connectors, using external interfaces, that will not make any impact in collaboration and would be easy communication among modules. Point 7, the design should be able to handle the events which are not assumed or not required, and the functioning of the design, the functioning of the software should go smooth. Point 8, as we discussed in last class, with Jemmy's example. Design is not coding. We are looking at the architecture and we are looking how the software should be made, and this is very different than the coding. At the coding, our focus is normally at one module and we are looking at the functionality of the one module, and then we jump to another module and look at the functionality of another module. So coding is not design. So design is more broad and taking everything into consideration. It's like unification. Point 9, the design should be checked for quality when you are creating the design, and it is very important that your design should meet the quality attributes. 10, the design should be followed and should be verified to minimize the errors in the software, because sometimes it happens that programmers are trying to implement something and they may go a little left or right of the design, and that will create a big problem later. So it is expected from the coders that they will follow the design, and it is expected from the designers that they will give enough details in the detailed design which will help the programmers to understand even the minute details of the software, and there should be no ambiguity in the design, so that every programmer, whoever sees the design, should be able to understand the same thing and should be able to implement. Design concepts. This we will see in the next class. We did discuss this in brief in the last class. We will talk more about these concepts in detail, and we'll see how they are useful in making a quality software.